students, welcome back. Let's continue with the top-down parsing. So the top-down parsing, I said it is of two types. One is uses the backtracking concept, and another is non-backtracking. So the non-backtracking one is nothing but the predictive parser. Predictive parser. Okay, so this I already explained in the previous video. So what is a backtracking and what is a predictive parser? So the predictive parser uses the concept of LL of 1. LL of 1. So with the help of LL of 1, it is going to scan the input tree, whatever the tree that is generated, that tree is matching to the input string or not without using the backtracking concept. Okay, so that's clear. Now let's see what is this LL parser. So in this video, I'll just give the introduction part of LL parser. In the next video, I'll take a simple example to solve the LL parser. So the LL parser accepts LL grammar. It accepts LL grammar. And it is denoted by, as LL of K. So LL of 1 or LL of K or LL, all are same. So it is denoted as LL of K. So what it means? What is first L? The first L is the input from left to right. So the first L represents the input. It just scans the input from left to right. And the second L acts as a leftmost derivation. Leftmost represents the leftmost derivation. The first L represents the input from left to right, and second L is does the leftmost derivation. And what about the K? The K is the number of look-aheads. Number of look-aheads in the input string. Okay, how many that input terminals are present in the grammar, and the non-terminals and the terminals both are. Okay, how many terminals and non-terminals are present in this? So that is the number of look-aheads. How many times it is going to be track the input string. Okay, so generally K is equal to 1. So therefore LL of K is equal to LL of 1. Both are the same. Generally K is equal to 1. So this is a parser. LL of K means L is a left input from left to right. Next L is the leftmost derivation, and K is number of look-aheads in the grammar. Now let's see what LL of parser definition. A grammar G is LL of 1. Okay. Suppose if whatever the grammar that is taken, that is LL of 1, if there are two distinct productions, so let us take a grammar G is LL of 1. If there are two distinct productions, so what are the two distinct productions? Let us take A tends to alpha, A produces alpha or beta. So these are the two distinct production. A grammar, whatever the grammar that is taken, that grammar is consisting of two distinct production, alpha or beta, with the following conditions hold. So that two productions, alpha and beta, is holding some conditions. So what are those conditions? For no terminal alpha and beta, derive string begin with A. So for no terminal of alpha beta, derive string beginning with A. So that is the first condition it has to be followed if it satisfies the grammar LL of 1. And second one, at most one of alpha and beta, in the production of alpha and beta, at most one of alpha and beta can derive empty string. So either alpha can derive empty string or beta can derive empty string. And third condition, suppose if beta produces epsilon, that is an empty string. Suppose if beta produces epsilon, then A, that is a terminal, A does not derive any string, beginning with a terminal in follow A. So suppose if beta produces epsilon, then A, whatever the terminal that is present, that A does not derive any string beginning with A terminal in follow A. So in the same way, if alpha produces epsilon, then A does not derive any string beginning with terminal in follow A. Okay, so this is a definition of LL parser, means the conditions that a grammar G is LL of 1, then it has to follow these conditions. Okay, so if it follows these conditions, then it can solve the tree, whatever the tree that is going to be generated, that tree is matched with the input string without backtracking. Okay, now let's see some data structures used by LL1. So what are the different data structures that used by the LL1? LL1 use a data structure. The data structure used by LL1 are input buffer, stack, parsing table. So LL1 uses a data structure, input buffer, stack, parsing table. So let's see the structure of LL1. Let me write the structure of LL1. So what I said in the previous video, so whatever the structure that I explained in the predictive parser, that in that structure all the string, that is the input, stack, input and the parser, all are same, but only the difference is the parsing table is the difference. So now let's see what are the data structures that used by LL1 is, that is the input buffer, stack and parsing table. Let's take this is the input buffer. Let's take A is one terminal, plus is another terminal, B is another terminal and ends with the dollar. So which indicates that the stack consumes all the strings. So whenever it reaches the dollar. And next coming to the stack. Stack first contains dollar, which indicates the empty stack. Next S is a starting symbol. The grammar starting symbol is placed on the stack. And here LL1 parser. So LL1 parser is first connects to the top of the stack. Okay, and it produces output. Now here a parsing table is constructed. So this is the parsing table. So this parsing table is different for different grammars, different concepts. So let's take a non-terminals on these rows and the columns is the terminals. So what are the terminals that we are using here? A plus B dollar. So these are all the terminals. The terminals are placed on the columns. And here let's take the non-terminals A, B and C. So these are the non-terminals, which is produced by the production S with the start symbol. Okay, so this is a parsing table, which is a two-dimension table. So here with the help of the input buffer, the LL parser is going to generate, store the values in the stack. Okay, with the help of the parsing table. And finally you will get the output. So to construct a predictive parser of LL of 1. So this is a structure. So the main thing is, with the help of this structure, you are going to construct a predictive parser. So to construct a predictive parsers, they have to follow some conditions. So in this video, I just write the rules, what you have to do, what are the different steps that you have to follow to construct the predictive parser. Construction of predictive LL of 1. So what are the rules that you have to follow? Means what are the steps that are taken place to construct the predictive parser LL of 1? The first thing is, what you have to do. First or leading function, follow or trailing function. The first step is, you need to construct the first or leading function or follow or trailing function. And the second step is predictive parsing table by using first and follow functions. So first you need to find out the first and follow functions, either leading or trailing. So after finding out the first and follow functions, you have to construct a table, that is a predictive parsing table has to be constructed. By using these two functions, you have to construct the table. Okay, fine, I constructed the table. So after constructing table, what I have to do? I have to parse the input string with the help of the table. Okay, the final thing is, we have to parse the input string. So whatever the input string that is there, that has to be parsed, and that has to be matched to the finally whatever the string that you produce, that has to be matched. So first thing is, you need to construct first function and follow function of it for the given grammar. By seeing these, with the help of the first and follow functions, we have to construct a predictive parsing table. So by seeing the table, with the help of this table, we have to parse the input string. So these are the three steps that you have to follow while constructing the predictive LL of 1. So the example, with the help of example, you can understand what are these steps, how you are going to construct find out the first and follow for the predictions, and how you are going to construct the table, and how to parse the input string by taking one example. Thank you.